Welcome guys to our Java course. Previously we had issues with running our code here. We couldn't get the desired output. Let me compile this again. Java C and hello dot Java. Then press enter. You will see that we can't get the desired outcome. What could be the issue? So I'll first begin by explaining how Java works behind the scenes. So remember what I told you in the first videos, that Java is one of the advantages that you get with Java is that it is platform independent, meaning it can run on each and every platform. Name it iOS, Android, each and every platform that you want. But the issue is our app, this application that we have just created. This is just locally on my machine. You can see here, it is on my local machine, meaning this one I can't run it anywhere. It is just here. So what Java did, what those guys did, they introduced this JVM, the Java virtual machine. This simply is a machine installed behind the scenes to run your Java applications or execute your Java application. So let me explain this. Like let me say you're having a friend, and a friend speaks another language. Remember here we are writing you can see, you can also read system.out.print.hello, but remember what I told you previously. This code has to be compiled to the local or to the language a computer understands. So this is done by what? By the JVM. So let me explain this by, let me say you're having a friend, and a friend speaks a native language, like another language, and you also speak another language, but you all want to communicate. So what you do, you get a middleman in between, and this middleman understands both your languages. So you use that middleman to communicate. So in this case, the JVM is our middleman, meaning the JVM will understand what I'm writing and what and the byte code. The computer understands byte code. So this means that in order for this to work, in order for my code to work, it is using the JVM. The JVM simply is turning my plain code to the byte code. Simply, let me say you're having here developer, here you are here developer. So you are the one writing the what? You write the code. Let me put this here. Text. You are the one writing the code. You are the developer here. You write your code here. I can first remove this. I can put this here. So you write your code. I can put this here. But remember, we are writing plain code, not a machine code, but plain code, which is understandable. Plain code. Like you can understand the words, what you are writing. It is simply easy for you to understand. But remember, the computer understands. Remember, the computer understands only byte code. Meaning, for my application to run, the computer has to execute byte code. Meaning, we have to first change this plain code into what? Into the byte code for it to be understood by the computer. So we shall need, that's why we need the JVM. It executes byte code, meaning the code that I'm writing is going to be executed by the JVM. This is like our middleman between our computer, our hardware, and our application. Remember, our application is not platform independent. It is single platform, meaning my application is just going to run on my local machine. But in order for my application to run on each and every device, let me show you having here. let me say having like iOS, I, iOS, you're having let me duplicate this, you're having something like Android, you're having Android, Android. You want your application to run on each and all devices that you have. Name it anything that you want. The JVM, this JVM, will have to execute or will have to change the code that you are writing to fit these two these two platforms. Meaning the JVM behind the scenes is the one which is platform independent. It will run on each and every on each and every device. But remember, this code here that I'm writing has to be compiled. The JVM does not compile, meaning we need a compiler in between. So I'll come here, put here, sorry, I'll need here shape, yeah. So we need a compiler here in between. This compiler simply is going to just, when I write here my code, it is going to compile the plain code that I have written. I can say text Java compiler, but this one is Java compiler. But remember, you can do a shortcut and I say Java C. So what does this mean? This compiler is going to compile my code that I have written, this one, the code that I have written here. My compiler will just compile my code here. Remember the way we used to do, you write Java C. We want to compile this code that I'm writing, the plain code. This is the plain code that I'm writing, and I specify the file .java, then execute. Meaning this compiler is trying to compile my plain code. So this is what it is doing here. After writing my plain code, I have to compile my plain code. After compiling my plain code, I will get an output. So I'll put here, I'll get an output. Which output am I getting? Here I'm getting the byte code. After compiling, they will give me the byte code. But remember, before the byte code is given, remember, before compiling here, we have what we call the main methods. This compiler here has to look in all your files that you created, and it has to find the main method. So what are the things that we find in the main method? Or you can have many classes here. Let me say, you can create many classes like welcome.java. You can have many classes here, but these classes won't work anywhere. These files won't work anywhere. This compiler is going to look at the main entrance. Our main entrance has to have some characters that this compiler will be looking for. Meaning, in all the code that you are going to write, we have to have the main entrance, which is the main file. So in Java, the main file is the one being compiled, not other files, but the main files. Meaning each and every file that we create, it's like a tree. The branches on a tree, but the main stem in between is the actual tree. Meaning here in programming or in Java, our main file has to have some unique characters that distinguishes it from other files. Meaning it can have like, these are the things that the compiler looks for before compiling. It has public, static, void, then main. Then inside the main, it has string, then arguments, which is this, and close. I'll explain this later. You don't have to get scared. I'll explain this later. So what I'm trying to explain here is that our compiler here is going to look at, is going to go into our application to find, are we having this method here? Are we having this line of code in one of the files that we created? Remember, the application can have multiple files, but to compile our code, it will just simply look for a specific line of code or a specific method for it to compile. Meaning, it will ignore others and find a method which looks like this. meaning our file or our code or our program has to have what, a beginning point or a starting point. So after finding it, what happens here? The compiler compiles the code and we get the bytecode. Simply after compile, you write the code. The compiler compiles it simply by looking, are we having this method here in our code? Are you letting me in? Are we having the main entries? After it is compiled into the bytecode, which bytecode is then let me get here some arrows. Which bytecode is then run back to our JVM. Remember, our JVM is our interpreter, which is going to interpret our code or execute our code. Remember, after after our compiler changing this into bytecode, it is going to send the signals to our JVM. Remember, our JVM is communicating direct to our device. Meaning, this code has to first be changed to bytecode from plain code using our compiler. From our compiler, after changing this to the bytecode, we change this bytecode is run by or executed by JVM. So meaning our JVM is our middleman. After this, our JVM, what will our JVM do? Our JVM will produce the output. This will be our output. That will be our output. After everything being, after the machine or after the JVM communicating direct to our machine, it will bring out the output. So this is the whole process how everything works. This is how everything works. From writing plain code, we compile the code into byte code. After byte code, the code that is compiled to byte code, it is sent to the JVM. The JVM, remember, is our middleman communicating direct to our devices here. After JVM executing, it will bring out back our output. But remember, there is another thing that you have to note in this layer. So on top of JVM here, where is our JVM? On top of JVM, we have what we call the JRE. What does this mean? This means here, this stands for Java Run Time Environment. This simply means on top of the JVM, we have what we call the JRE. So this one is inside this one. Can put this one here. Can put this one here. Can put this one here. I can just close this and just rename this to the Java Run Time Environment. Yeah, this one here. Can delete this. So what does this mean? On top, just bring this here. I want to get here some line. What does this mean? Simply the JRE is also a compiler, but remember, some computers or some devices don't have this jack, the compiler here itself, and some computers does not have this package that we installed. Remember the package that we installed last time, the Java development kit. Not each and every computer has the JDK, meaning behind the scenes, what Java does is we create the Java runtime environment. Simply, this means all the JVM is inside the Java runtime environment. So when we check that we don't have the JDK and we don't have the compiler, this runtime will run our JVM. So from here, we compile, our runtime compiles it to bytecode. Then inside we are having the what? The JVM that interprets. So when we check that a computer does not have a compiler here, the runtime simply is the one that executes what? Our tasks before sending the signals to the JVM. So on top here, on top of the JVM, we are having the Java runtime environment, meaning the environment is the one what running and executing our code if we don't have the compiler. And on top, as I have explained, we are having our here down. Can put this here down, and on top here, a moment. On top, uh, on top here, let me first reduce this. On top here, we are having this. This is too long. First, try to increase a minute. On top here, we are having our what? Remember, our JDK, which is having all these, the runtime environment and the what? And the JVM. So meaning these are all here inside. Just increase this. Meaning this, the JDK inside, we find the JRE, the Java runtime environment. Now inside the Java runtime environment, we get the JVM. So basically that's how our code is executed in Java. And basically that's how our code is executed in Java. So I'll just put this here. So after it can, the JDK is the one having all our tools or kits that we need. And now inside the JDK we find these two, the JRE and the JVM. The JRE is the Java runtime environment, and the JVM is our Java virtual machine which executes our tasks. And this one, the JRE, is the one responsible for our runtime or for running our Java code. So after here we get our output here. This arrow can first remove this. We get our output after everything is success. So this is the structure how everything has to work. But remember, for us to run our code here, and remember Java is object oriented, meaning everything is written in objects. But in order for us to write here, first remove this. In order for us to execute our line, this line, it has to be in what? In a class, or in an object. Remember, Java is an object oriented language. So I'll say public. Remember this line here, this one, can increase this. This line that I previously explained. For our code to run, this one, the compiler first looks in your code. Are you letting me in? So my main interest is looking mainly for this line here. So meaning in my hello world, I'm going to just write that line, this one here, the public static void, then main. This is our main. Then inside the main, I'm having string. Inside the main, I'm having string. String, then arguments. I'll explain this in the videos to come. What simply this means. Now inside here, I can put this line inside my code here. String has to be capital. Yeah. So this is so far what I'm getting. So when I try to run this, you first compile JavaScript, then hello.java. Remember, to compile you have to first tell Java where is your plain code. Simply my plain code is on hello.java, then enter. Meaning, so I'm having here an issue. Declared classes are preview feature are disabled by default. Static void, having here some issue. Say class, then say main, or I can say hello. Then inside the class, I can paste this our code here inside, meaning the main method has to be inside an object. So when you are creating an object, you have to first create a class. I'll explain this in the coming videos. So let me try to run this java c hello dot j dot java. Press enter. Oh, it is running. So what does this extra class that they have created, what does this mean? This simply means, remember what I explained earlier. After compiling our code, after writing the plain code, I have compiled the code. After compiling, they have to create a bytecode. The bytecode is the one the machine understands. Remember, the machine understands bytecode, the ones and zeros. So this class here that they have created, they have just changed my plain code into the bytecode, meaning in this class they have created an extra class, which is inside here is the bytecode that you'll find there inside. That's the extra class that they have created. Meaning here, this is my plain code, and this is the bytecode that they have compiled out of my plain code here. Meaning here, I'm having access to the bytecode, meaning the machine now can understand this. So I have to execute. So Java. Now for running, I have to run this, the hello class, but I can just say Java, then I run. No need to write the class, just write hello. Here, you will see success. We are having hello world, which I'm printing here system.out. I want to print out the word hello world. I'm getting it here. After, let me explain a little bit. After the code is compiled into bytecode, I'm not running the plain code. I'm running the bytecode that the code has created. The code has compiled and given me the bytecode. So I'm running this. That's why here I'm saying Java hello, the hello class, then enter. You can see my output here. So that's how we run, and that's how Java works behind the scenes. You first create an object. Remember, we are in object oriented. After creating an object, we put inside our main class or our main method. So in compiling behind, here I'm writing plain code. That's why you can read public static void main string. You can read all these things, but the computer does not understand this. It has to change this to ones and zeros, the bytecode. So after I compile this code, after compiling, they will create the bytecode. After the bytecode is being created here, after compiling here, using the jack, we shall get output, we shall get our output, which is our bytecode. Now our bytecode will then send the signals to the JVM. The JVM will be able to output our our output, the one that we want. But remember, the JVM is using the JRE, the Java Runtime Environment. They are all inside the JDK. So simply, that's how our code, how Java works behind the scenes. Thank you guys. In the next video, we shall see something even more nice. Thank you. Meaning this has to run inside the class. So I'll cut this, create a class. Sorry, create a class.